Good morning, guys. I have a whopping 15 minutes to show you how to do the algebra of random variables using the rules that we learned on Friday. So we're going to get right to work and go pretty quickly. You can pause if you need to get caught up from time to time, but I'm going to have to just hit the ground running to get this all in. So we're going to look at page 409 of the textbook, numbers 30 and part of 32. To see what happens when we take some random variables, x and y, whose mean and standard deviation we know. It's all we know about them. We don't know the actual data values. So kind of think about that Detmer-Dogs activity we did on Friday where x might be the weight of a hot dog and y might be the weight of a bun. We don't know the individual weights they could be, but we do know what the average is. We do know what the standard deviation is. So we have a bit of a different situation in that all we know are the summary statistics. So all we want to do on this particular problem is this is number 30, look at different combinations of the variables and constants and see what the new means and standard deviations are. So the question is, if these are independent random variables, x and y, what are the means and standard deviations of these quantities? So we'll start with part A. In part A, we're looking for the mean and standard deviation of x minus 20. So I'm going to start with the expected value notation, and then we'll switch over halfway through so you can see a little bit of both. We want the expected value of random variable x minus 20. And we want to think about this as you have some variable x that has some possible values, but we don't know those possible values. We just know that we're decreasing each value by 20. It's like taking those hot dogs and make each of them 20 ounces less. The rule for expected values, which are the same things as means, is to just, if you subtract a constant from the variable, you subtract that same constant from the mean. So algebraically, we'll just rewrite this as e of x minus 20. So basically, we just pull that 20 out. So if each variable is 20 less, then the mean is 20 less. And the mean of x is 80. So e of x, we have that value in the table. Subtract 20 from that. So we're substituting here. And 80 minus 20 is 60. So the new mean is 60. So if the variable is decreased by 20, then the mean is also decreased by 20. That makes sense. Standard deviation we're going to do a little bit differently today. We have been doing that as a two-step process. We do the variance first and then take the square root of the result to get the standard deviation. We're going to save a little bit of work by doing it all at one time. So I'm going to just start with standard deviation of x minus 20. But the issue with standard deviation is that our rules don't actually apply to standard deviations. The rules we learned on Friday apply to variances. So the first thing I'm going to do every time is rewrite that as a variance problem. So standard deviation is the square root of the variance. So we're going to rewrite this as the square root of the variance of x minus 20. That's equal to the square root of, well, variance is a measure of variation or spread. When you take every value in a data set and decrease it by 20, it makes every number smaller, but the spread between those numbers doesn't change. They're just as spread out as they were before. So that minus 20 actually doesn't do anything to the spread. So we're just going to drop it because it doesn't matter. So adding, subtracting a constant never affects a measure of spread. So we just want the variance of x there. So square root of variance of x, we don't actually know the variance of x, but if we look in the table, we know the standard deviation of x. And the variance is the square of that standard deviation, so that's equal to 12 squared. And the square root of 12 squared is 12. So we find out that the original standard deviation of the variable is 12, and even after we subtract 20 from the variable, the spread stays the same. It's not affected at all. So all we're doing is just some algebra of random variables here. We just have to get accustomed to these variable rules and know how to apply those correctly to the different situations. So we're going to move on to part B. Part B, we're looking at 0.5y. We want to know the mean of that, so mean of 0.5y to start with. So we have some variable y, we take half of every value. That in turn makes the mean half as big as it was. So we'll pull that 0.5 out and multiply by e of y. So basically you just pull it out. So half of the variable is equivalent to half of the mean. E of y, we can substitute a number for that. E of y is the mean of y. If we look in the chart, that's 12. So 0.5 times 12, which is equal to 6. So half the value of y means half of the mean of y. Standard deviation of 0.5y. First, we'll write it as a variance. So that's the square root of the variance of 0.5y. And that's equal to the square root of, well, variance is, it works similarly to mean in that you pull the 0.5 out. But since variance is a squared quantity, you have to square that after you pull it out. And then that leaves behind variance of y. So just pull the half out and square it. If we do some substitution, that's the square root of 0.5 squared times the variance of y. We have in the table the standard deviation is 3, so the variance would be 3 squared. And then if we do some number crunching, that's going to give us a total of 1.5 after we crunch that out. Part C. We want the mean and standard deviation of the sum of two random variables. So this is like the dog plus a bun step that we did on Friday. The only difference is we don't know the raw data. So we have to only work with the summary statistics. If we start with the expected value of x plus y, we learned on Friday that the mean of a sum is the sum of the means. So we just separate that out as two separate means. So that's equal to the mean of x plus the mean of y. Once we get that separated out, we can substitute in mean of x from the table. Mean of x was 80, plus the mean of y was 12, and 80 plus 12 is 92. The variance, well, we'll start with standard deviation of x plus y. Rewrite that as the square root of the variance of x plus y. And variances do add, we learned on Friday, so that's the square root of the variance of x plus the variance of y. And then we're ready to substitute. So that's equal to the square root of variance of x is the square of its standard deviation. Standard deviation was 12, so 12 squared, plus variance of y is 3 squared. That one we'll need a calculator for. Square root of 12 squared plus 3 squared ends up being a decimal number of approximately 12.37. Now on part D, we're going to switch to the other notation just to kind of get a look at that. We need to be able to go back and forth between the two. Now for the mu notation, instead of the e of x, you've got a couple of choices. One is to use subscripts. I don't really care for the subscripts because they get so small that it's hard to read. So you are allowed to use a function-like notation with the mu's and the sigmas. So that's what we're going to do this time. So instead of an e of something, we're going to do mu of y x minus y. So the mean of that difference. Means just, they sort of distribute. You just take the mean of each variable, mean of x, and subtract it, mean of y. Separate it out. Okay, mean of x is 80, minus mean of y is 12, and 80 minus 12 is 68. And then the standard deviation, which is sigma of x minus y. We're going to rewrite that as the square root of the variance. Variance is sigma squared of x minus y. Variances add, just like they did in number C. When we have more variables, we have more variations, so we add and we get something that looks very much like a Pythagorean application. Same thing's going to happen with subtraction. So when we separate out those variances, we take the variance of x and add the variance of y. More variables means more variation. So that's square root of sigma squared, that's the variance of x. Variance of x is 12 squared, plus variance of y is 3 squared. So it looks exactly like part C. Adding variables, subtracting variables, you do the same process with the variation, with the variances. Again, this looks like the square root of a squared plus b squared. That's a Pythagorean operation. We get the same total, 12.37, that we did for part C. Part E. We want the mean of y1 plus y2. So two different y values. So think of this like the dog and dog deal on the Friday activity, where we have two different dogs. They might be two of the same size, they might be two different sizes. That is the same rule that applies to two different variables like number C. So we'll just split that up as mean of y1 plus the mean of y2. Mean of y1 is 12 plus the mean of y2 is 12. Y is y, so they have the same means, and that's equal to 24. Standard deviation sigma of y1 plus y2 is the square root of the variance, square root of sigma squared of y1 plus y2. And variances add, so that's the square root of sigma square y1 plus sigma square of y2. Standard deviation of y is 3, so if we substitute, that's going to give us the square root of 3 squared plus 3 squared, which is the square root of 18, and that's approximately, oh, to have a pencil, 4.24. Okay, we're going to skip to 32A. I'm going to try to squeeze this in before my 15 minutes runs out, where we're looking for the mean of 2x plus 20, just to show you quickly what happens when you do multiple operations. So we need the multiplication rule and the addition rule. So we'll pull the 2 out and do 2 times mean of x plus 20. So we're just doing 2 steps in one. And then we know that the mean of x is 80, so this is 2 times 80 plus 20, which is 160 plus 20, which is 180. And then the standard deviation of 2x plus 20, which is the square root of the variance, sigma squared of 2x plus 20. We'll apply the multiplication rule. We pull the 2 out and square it. Then sigma square of x plus 20 drops away because adding subtracting does not affect spreads. Then 2 squared is brought over. Sigma squared x, well, x has the standard deviation of 12, so this is 12 squared. And the square root of 2 squared times 12 squared is 24. Okay, out of time, you'll get your assignment from the sub, and tomorrow we'll look at a word problem.